I just wanted to kind of show something that I was working on a little while ago. Basically, the concept is a mask-based lighting system using a hack in Dreamseeker. I'll explain the hack in a minute, but I just want to show you what I mean by a mask-based lighting
I
system.
only have 12.
Um, Now, in The Legend of Zelda, Link to the Past, there's a part in the game where you are going through the sewers, and in those sewers, you actually have a lantern. As you can see here, the whoa, lots of video artifacts there. Anyway, um, the lantern lights up an area, yada yada. I mean, this is what I'm talking about with masking, where you hide something behind a black curtain, essentially, and then you cut out a shape on that black curtain in the shape of the lighting area that you want. Uh, in the case of The Legend of Zelda, there's only one light source, so that's actually doable. But in a multiplayer game, you really can't have more than one light source, or you can't have just one light source. It just won't work. So um, having more than one light source really breaks the concept. So that's why you need masking. Now, the way that I approached this was through a Dream Seeker hack. Essentially, what I did, and as you can see, it's working here fairly well. Excuse the roughness of this mock-up, but I mean, I put it together in probably about 10 minutes. Um, Basically, what I did was I layered a window over Dreamseeker and set the transparency color to the background of the window. And then I put a map on that window, and every time the player moves, I reposition the lighting objects that are in his viewport. Actually, the code that I used is really efficient. It uses a differential map. It doesn't actually loop through the player's viewport at all points. It really only it really only looks for things that are going to change uh, based upon the movements that you use. Now you'll notice some of the lights are off-centered, and I did some of my math wrong. It doesn't really matter. The point here is that it's a proof of concept. We've got mask-based lighting working. Unfortunately, it's a hack. Doesn't work very well on some graphics cards. Doesn't work very well on Windows XP. Does not seem to work at all on Windows 2000, and I'm frankly not sure about emulated versions. So yes, the web client is going to be superior to any Dreamseeker based hack approaches for layering transparent elements on top of the map. One of the major issues here is if I drag another window over it and then, well, there we go, and then click on it, yeah, you'll notice that this transparent window overlays this. Now, I could prevent that by making this transparent window disabled, but that would make it so that I get the annoying Windows ding sound every time that I click on the disabled element. Plus, it would make it so that I can click and drag the element away from the window and get it out of position. Now, I actually have a hidden browser in this interface that's running a JavaScript on update loop about once every 10 milliseconds to check if the main window has been moved and then update the position of the sub window, which is layered into the main window. Now, that's ugly. Anybody that knows anything about programming, like, you just don't do that. You don't do constant update loops for polling. Um, the GDI update commands, I saw somebody posted that they do actually have an on-moved event. It would be nice if we had access to that, but being that Beyond was designed as a server-side language and this is a complete hack, I don't see any point to implementing it. I mean, it's overboard. The web client would allow something similar to this. The only problem, again, is that you wouldn't be able to do a HUD with this kind of a system because the HUD would have to be layered over this, so you'd need a third client-side element on top of the map that would give you access to a HUD. Um, so that would take away all of your object interaction directly on the server side. So it would really fragment your development flow. There's more problems with it, but here's the really big one. Yeah, like I said, it's ugly and borked and just a really bad approach. I'm amazed that actually worked. That didn't work. Okay. Yeah, so it's kind of an ugly approach altogether. I mean, it's cool as a novelty, like most of the crap that I do, but frankly, it's not going to it's not gonna work for presentation purposes because people aren't really going to expect a something that's this borked being in a playable game. I mean, it just doesn't meet the presentation qualities of a game. So really, it's better to just not do it, frankly. Now I can kind of show you the environment a bit where I implemented this so you can kind of get an idea. This was 5-minute code, so you'll have to forgive the terrible nature of it. Let's see here, and nope. Physics collision, X-style stuff. There it is. All right, so you have to forgive the kind of terrible nature of it. Basically, I just have a bunch of movement functions here. Um, it determines what masks enter and exit the view, repositions masks based upon the movement of the viewport, and it will detect teleports and fully rebuild the view, searching the entire view when necessary. Honestly, this could be improved with a binary tree approach, basically a binary space partitioning approach. But it didn't need it for the purposes that I had. It works all right over multiplayer, just not on certain people's graphics cards, which I already mentioned. And honestly, all of this is it's weird. It's weird and ugly and kind of stupid, but it does demonstrate some of what you can do with JavaScript and DM. Let's see here. Where is my JavaScript code? File, open project folder. Now, the JavaScript code is going to, here we go. Oh, wait, no. Nope. Okay. JavaScript code is, well, pretty simplistic. Basically, all it does is check to see if the base window is moved over an interval of 10 milliseconds. That's really it. Um, I also set up some callback stuff, and yeah, it's pretty similar to a bunch of my approaches. But yeah, I mean, like I said, as you can see, I'm doing the client win set here, and I'll show you the interface while I'm at it. Interface, I've got window 1 is the debug output, and window 2 here is actually the map element. I've got it set as a light map, and the options are, see here, appearance, anchors, top left, bottom right, appearance style. That's right, it's going to be under the window. So we'll go into edit here. And these are the really major options here. It's the transparent color and image. I set it to pure black, and the background transparency is off. You could actually set that to give it like global, global lighting, but it just, I don't know, it's ugly. It just doesn't work well, and I wish I could do better than that, but it's just the nature of Beyond as it is being server-side driven. Um, these are the masks for the lights. These are the multiplier cookies for the lights. Basically, they just put that blue stuff in the background like you saw. As you can see now, this might make a little bit more sense now that I've kind of shown you how things work internally. But, the thing about the web client is it allows you to do more. But it doesn't really allow you to do anything that wasn't already possible. It just allows you to do it without hacks. Like I said, these are really ugly hacks, and I don't see anybody but me using them, and I don't see them being viable. I really wish we had something more tangible than the current state of the web client. I don't like a lot of the aspects of the web client. I don't like the fact that we're not going to get access to the render loop. I don't like the fact that there's no framework to inject client-side atoms into the viewport. I don't like a lot of things about it. I think certainly there's a lot of need for improvement within the DM language, and specifically if we're gonna move over to the web client, I do hope that Tom is he has the foresight to write a DM transcompiler that will take DM and convert it into Dart directly, and simply make Beyond an API built upon Dart from this point forward. I don't know what the speed consequences of that would be versus our existing architecture as a VM versus Dart's VM itself. But it could be faster, could be slower, could be a trade-off. I don't know. I honestly don't know. I can't really get a good handle on how fast Dart is because I just don't really work with it. Um, Overall, I mean, and it is really browser dependent. It's faster in some browsers than others, and so on and so forth. But I mean, that's pretty much what I got to show you at this point, and that's pretty much the end of my rant. So take it easy.